Hello friends, welcome to Time Classes. Today we're going to deal with a very interesting topic and slightly difficult. Difficult because you've not done this earlier. This is something new for you and therefore it's difficult. But then it is very interesting and it involves a little bit of deep thinking. This is a topic on reasoning. So we're actually going to do something connected with logic, right? And I'm sure none of you may have done this kind of reasoning. Although the methodology that we're going to use is quite familiar to you. So we're going to learn something more than what you've already learned out of that concept. Actually, what we're going to talk about is Venn diagrams. So we are going to talk about logical reasoning through the help of Venn diagrams. Anyway, so what I want to tell you is that these kind of questions, based on reasoning or logic, they come in our entrance examinations. They are a very important part of the entrance examinations, particularly the law students. All those who are going to sit for law entrance exams, make sure that you're going to get many questions on logical reasoning. And reasoning per se includes two areas. One has questions based on numbers, and that is therefore based on mathematics or quant. The second reasoning is based on the language, and this is what this reasoning is about. It is about the language. So we're going to do logical reasoning in which the concepts are languageably understood, and this is a very important part of all exams. But yes, for law students, it is the involvement of this concept is much more than the other non-law entrance exams. All right. So we begin with we actually are going to do two topics in this uh, section, but today we are going to talk about only one concept, and that concept is called syllogisms. Some of you may be familiar with it, but most of you, I'm sure, will not know what syllogs or syllogisms are. Syllogisms, the basic concept of syllogism says that we require two valid statements to draw a valid conclusion. So we don't draw a conclusion from only one statement, we draw it from two statements. All right. Just to define syllogs for you. In a question based on syllogism, we are given two statements and we are asked to draw a valid conclusion or more than one conclusion also. So we may be asked to draw valid conclusions. All right. So in a set of options, we are supposed to find out which conclusions are true according to those two statements that are given to us. Right. Uh, these kind of questions can come in quant section as well as the verbal section, but they're more prominent in the verbal section. All right. When I talk about a valid conclusion, please remember sometimes we all know what valid is. Valid is something that is true. Now, sometimes we are given very weird statements. All right. Weird statements in the sense that they may be factually incorrect. For example, this is, of course, a very valid statement. I can get a statement which says all students are intelligent, but sometimes they are very, very factually incorrect. For example, it may say that the sun rises in the east. Now, you'll have to take for granted that the sun rises in the east and then what follows from it. All right. So, when we talk about a valid conclusion or statements, it does not mean that it has to be factually correct. Whatever the given data is, we are supposed to draw some valid conclusions out of it. All right. So accept your data as it comes. Don't worry about it being factually correct or factually incorrect, because we do come across some weird statements. Before we move on to that section where we are going to talk about some weird statements, let's take this factually possibly correct statement. All students are intelligent. Now, very simple statement. This statement has two main words, students and intelligent. Both these words are called terms. In the concept of syllogisms, we call these two words as terms. Student is one term and intelligent is another term. The student which comes first in the statement is said to be the subject of the statement. The term that comes first in the statement is called the subject of the statement, and the term that comes second in the statement is called a predicate. We are also using some English grammar jargon, all right, because it is based on the English verbal reasoning section. So the jargon that we are using is also related to grammar, right? So students is a subject here and intelligent is a predicate. Okay. We have another word also here, and that is all. All is said to be a quantifier, because when I say all students are intelligent, what is telling me the quantity of the subject? The word all. Therefore, the concept calls this word all to be a quantifier. The concept further says that there can only be two quantifiers in a statement under the concept of syllogisms. That means we can only consider two kinds of quantifiers in syllogisms. Sometimes they also call it a qualifier. They call it a quantifier or a qualifier because it tells us the quantity or how many students qualify to become intelligent. All right. Before I move further, tell me one thing. If I say all students are intelligent, then can it be possible that some students are not intelligent? The answer is no, because it very clearly tells us all students are exception. The word all means without any exception. All right, we have to understand the word very strictly. If it says all students are intelligent, then we have to understand that there is no exception. All right, therefore, there is no student who is not intelligent. Further, if I say all students are intelligent, can I also say all intelligent people are students? Or in other words, if all A's are B's, can I also say that all B's are A's? Should it not be true? All A's are B's and if all A's are B's, then all B's are A's is also true. Let's try to understand this. We should not say that it cannot be true at all. It's wrong to say it cannot be true at all. For example, I'll give another example. All Marutis are cars. Now, this statement, all Marutis are cars. Is it a true statement? Does Maruti make only cars? Answer is yes. We don't hear Maruti making any two-wheelers or trucks or motorcycles or something. Therefore, the statement all Marutis are cars is true. But is the reverse also true? All cars are Marutis? Answer is no, because there are several other brands that make cars or several other companies that make cars. Therefore, all Marutis are cars may be true, but all cars are Maruti is not true. All right. Now, imagine a very small country. Imagine a small country that doesn't have many manufacturers of cars. It has only one manufacturer of cars. Since it's a small country, the demand is very limited. Therefore, there is only one manufacturer of cars. All right. And that manufacturer of cars, and in that country, there is no import of cars allowed. So we have one manufacturer of cars, no imports are allowed of cars in that country, and that brand of cars that is being manufactured in that small country is called Maruti. Please listen to it very carefully. There is a small country, only one brand of cars is being sold there. Imports of cars is not allowed in that country, and the brand name of that car is Maruti in that country. So they make only cars. Therefore, can I say all Marutis are cars in that country? The answer is yes. Is this also true that all cars are Maruti in that country? The answer is yes. Therefore, to say that all Marutis are cars and all cars are Maruti can never be true. The answer, your thinking is wrong. In India, it is not true, but maybe in some country, if there is only one manufacturer of cars, then the reverse of the statement all Marutis are cars may be true. All right. So be clear. You cannot say that if all A's are B's, then all B's are A's is never true. We can always say that it is possible. All right. So we were talking about the quantifiers. So we have the concept tells us that there can only be two kinds of quantifiers. Because it talks about all students are intelligent, all is the quantifier, so it also tells us that we can have only two kinds of quantifiers. If we are talking about all of them, then it is a universal quantifier. And if we are not talking about all of them, then it is said to be a particular quantifier. I repeat, quantifier, the concept tells us there are only two kinds. We have to subdivide the quantifiers into two categories. One is a universal quantifier and the other is a particular quantifier. If you are talking about the entire category of the subject, then it is a universal quantifier. If we are not talking about the entire category, then it is said to be a particular quantifier. All right. I hope it is not very difficult to understand. Now, we have some synonyms for universal quantifiers, or we call these words to be universal quantifiers. For example, if I say all students are intelligent, it means without any exception. What if I say each student is intelligent? In that case, am I still talking about all the students? Each student is intelligent? Answer is yes. When I say each student is intelligent, in that case also, I am referring to all of them. What about every student is intelligent? Does that also talk about all the students? Answer is yes. Hence, that is also a universal quantifier because it is talking about all. What if I say none of the students is foolish? If I say none of the students is foolish, am I still talking about all the students? Do I know about all the students when I say none of the students is foolish? The answer is yes. Hence, none is also a universal quantifier. What about no student is foolish? In that case also, I am talking about all of them. Therefore, all these are they fall under the category of universal quantifiers. The words that we can use for a particular quantifier could be some. What if I say some students are intelligent? Am I talking about all? No. Hence, it falls under particular quantifier. What if I say most of the students are intelligent? Am I talking about all of them? The answer is no. Hence, most is also under particular quantifier. What about almost all? Is almost all talking about all without exception? The answer is no. Hence, almost all will also fall under particular quantifier. I hope it is clear till here. And I also hope that you are out with your pens and registers and you're noting down all the important points. This jargon that I'm talking about should not be very difficult. I'll take you back to the previous slide for you to understand something that you may have missed. All right. So make sure that you understand these statements, subject, predicate, quantifiers. The sample statement that we have taken is all students are intelligent. And from here, we move on to two types of quantifiers, all or universal or particular. All right, if you're talking about all, then it is universal. If you're not talking about all, only a portion of it, a part of it, then it becomes particular. These are the words that we can use for universal or particular. Right? So, done till here? Okay. Next, what happens is that we have to see a statement. The statement could either be negative in nature or positive in nature. All right. I don't use the word positive here, although you may understand it as positive. A statement can be negative or positive. I use the word affirmative. So treat the word affirmative to mean positive. All right. How do we see the difference between a positive statement or an affirmative statement and a negative statement? A negative statement will have a no or not. If the statement has a no or not, then it is said to be a negative statement. And if it does not have a no or not, then it is said to be an affirmative statement. I hope there is no trouble here also. A statement could be either affirmative or negative. If there is a no or not, then it is a negative statement. If there is no or not, then it is said to be an affirmative statement. All right. So, two quantifiers. A statement can be negative or affirmative. How many total kinds of statements can we have under this concept? The total number of statements that we can have is 4. I hope this is very clear. All right. How do we classify these 4 statements? We'll see on the next slide. But till now, what you should understand that you get any statement, it can qualify to be under one of the 4 different kinds of statements. We'll explain how to go about this, how to identify which category it belongs to. But first, the 4 different kinds of statements that we have, or what are their names. Check the quantifier. First thing that you have to do is whenever you get a statement, you check, am I talking about all or am I talking about not all? In other words, am I talking about the entire category or a part of the category? All right, if I'm talking about all of them, then it is said to be a universal statement. And if it does not have a no or not, then it is said to be a universal and also affirmative. All right. So look at the statement all A's are B's. All A's are B's. Am I talking about all the A's? Yes. And there is no or not. Hence it is called a universal affirmative statement. All right. Now look at the next statement. No A's are B's. When I say no A's are B's, am I talking about all the A's? If I say no A is B, am I talking about all the A's? Do I know about all the A's? The answer is yes. So if I'm talking about all A's, then it becomes a universal statement. And does it have a no or not? Yes, indeed. It has a no or not. Hence it becomes a universal negative statement. I hope clear till here. Next, examine the statement some A's are B's. When I talk about some A's are B's, am I talking about all the A's or a part of the A's? The answer is part of the A's because it says some A's are B's, even if it is a larger half. It still does not mean I'm talking about all of them. I am talking about maybe a larger part. So most or some, both would refer to a particular quantifier. All right. And does it have a no or not? No. Hence it should come under particular affirmative statement. All right. One more statement. Some A's are not B. Am I talking about all the A's? No. I'm talking about a part of them. Therefore it is particular. And does it have a no or not? The answer is yes. Hence it should come under particular negative statement. I hope you can now identify the statements to be one out of these 4 statements by looking at these simple rules, the presence of universal or particular, and then the presence of no or not, or not having a no or not. All right. Now, the conclusions that we can draw. There are different kinds of conclusions. Now we take one example, and that is all cats are dogs. I told you, we come out with some weird statement. So, syllogisms questions will have very, very weird questions. I mean, they'll be factually incorrect, but never mind. Don't be, flustered looking at these statements. All you have to do is look at these statements and try to take it as your data. All right, like we do in mathematics, you take it as your data and then try to work on the solution. All right. So when I say all cats are dogs, which statement is this? Can I say, is it a universal affirmative statement? If all cats are dogs, does it talk about all? Yes, it talks about all cats. Therefore, it is universal. It has no or not. Hence, it is a universal affirmative statement. I hope the point is clear. All right. Now, before I speak more on this, I want you to understand three different ways of knowing a statement. All right. Or knowing the conclusion. The first, I'll tell you what is uh, the Venn diagram. All those who've done Venn diagrams, I'm sure many of you have done Venn diagrams in school, but some of you may not have done Venn diagrams or probably did not understand the Venn diagrams very well, or some of you may not have done it up to 10th and then you did not have maths after 10. Therefore, uh, you may not have come across, and some of you are genuinely scared of Venn diagrams and therefore you attended the classes but you never understood a bit. Anyway, let me calm down those people who are a little nervous about Venn diagrams. We are going to do the very basics of Venn diagram. I'm going to do it in such a way, assuming that you people don't know what Venn diagrams are. So don't worry about learning the Venn diagrams. Just worry about understanding what I'm saying. Once you understand, you'll also learn the process. All right. So, just to tell you what Venn diagrams are pictorial way of talking about a statement. We draw diagrams to show the statement. All right. They are diagrammatic expressions of a statement. So when I say all cats are dogs, I am trying to create a category called cats. All right. This oval that you see on your screen is depicting the category called cats. Now, when I say all cats are dogs, what am I trying to say? I am saying that the entire category of cats is what? How is it connected to dogs? Does it come under dogs? Or does it come outside dogs? Or does it come equal to dogs? So what is talking about? It says all cats are dogs. So is it inside dogs or outside dogs? The answer is inside dogs. When I say all cats, it means that they are dogs. It means that they come under the category of dogs. So, in other words, I'm saying all the cats come under the category called dogs, or in other words, I can say all the cats are inside dogs. All right. Let's see a further depiction. So, when I say all cats are dogs, does it truly represent a pictorial expression of the statement all cats are dogs? It is telling us that there is a small oval which is inside a large oval, and the small oval is representing the cat category, and the large oval is representing a dog category, and the small oval is inside the large oval. So, is it a representation of all cats are dogs? The answer is yes. All right. Now, look at another one. Here, what I have done is I have taken two ovals and not one oval. You may not be able to see the second oval, but what I have done is I have taken one oval and I have taken another oval of the same size. So I have superimposed C oval on top of D oval. All right. So it has been superimposed. I have two equal sized ovals and I have superimposed one on the other, and therefore it seems to me I'm talking only about one oval, but do see it as two ovals, one on top of the other, because they are of the same size. We cannot see the overlap. All right. So is this also all cats are dogs? Are all the cats inside the category of dogs? The answer is yes. Hence, this is also, the first one is also a representation of all cats are dogs, and the second one is also a representation of all cats or dogs. Make no mistake in understanding this, both of them are talking about all cats or dogs. All right, now let's move a little further. We will have to decide among three options. Number one, we have to see that it is certainly true. Certainly true means that it is true in all respects. As I said, the first diagram is also true about all cats are dogs, and the second is also representing all cats are dogs. That means what we have to ensure to confirm that all cats are dogs or to make a pictorial representation of all cats are dogs, we have to make sure that the cat category does not go outside the dog category. Cat category can contract, become smaller, and dog category can enlarge. It can enlarge to no extent. It can go any extent in the enlargement. But cat category is restricted by its enlargement because it can't go beyond the dog category. Only then we can represent all cats or dogs. So a slight expansion of C is possible, but no way can we allow C to go outside the boundaries of D. So if D enlarges, then C also can enlarge up to the boundaries of D. I hope you've understood this. So we have to see that if all cats are dogs, then the first one is a representation, the second one is also a representation, and any diagram in between should also be a true representation of all cats are dogs. The second diagram seems to be the ultimate limit of all cats are dogs. All right, because cat cannot expand further unless dogs also expand. All right, so one option that we have in our mind is certainly true. That means true in all respects, true in all cases. And the second understanding would be certainly false. That means not true in any situation. All right. Now we have a third situation also, which is possibly true or probably true. When we talk about possibly true or probably true, then we have to keep in mind that it is not certainly true and it is also not certainly false. Because maybe if we have, let's say, 100 different, pictorial ways of uh, representing all cats or dogs, and in one situation, if it can be true, but in the other cases it is false, then we'll not say certainly false, we will say possibly true, because there is a possibility. In 1 out of 100 chance also, if you have a possibility of the statement being true, then it is said to be possibly true. And on the contrary, if 99 cases it is true, but one case it is false, then also we use the term possibly true. And possibly true is indicated with a dash. All right, till here? All right, let's move on. Now, what is the data given to us? All cats are dogs. All right, so we'll try to identify if all cats are dogs, which is the main statement or the data given to us, then what is true about the statement all dogs are cats? If all cats are dogs, then all dogs are cats is certainly true, certainly false, or possibly true. We discussed this at the beginning of the class. We said that we cannot say that it is always true. We also cannot say that it is always false. There is always a possibility that it may be true. For example, I gave you the example of Maruti cars. All right. So your answer should not be certainly true or certainly false. Your answer should be possibly true or probably true. All right. I hope you're able to understand this. Not very difficult. Okay. Again, now the data given to us is all cats are dogs. If all cats are dogs, then what is the situation of some cats are dogs? Let's understand the word some. What does some mean? What does some mean to you? Some means not all. So when I say all cats are dogs, then would some cats are dogs be true? Okay, let's understand. Let's say all Indians are honest. All right. Let us assume that all Indians are honest. I know 100 Indians only. I don't know all of them. So I know only 100 Indians. If the truth is that all Indians are honest, will those 100 be honest also or not? Think logically, think from reason point of view. Don't think the way we think in our everyday life or in everyday conversation. So when the truth is that all Indians are honest, then the 100 Indians that I know, will they also be certainly honest or not? Well, if the truth is that all Indians are honest and I am to believe that all Indians are honest, then those 100 will also be honest. But since I know only those 100 people, how will I confirm? I cannot confirm about the rest. I can only confirm about these 100. So how will I say it? Some Indians are honest. The truth is, all Indians are honest. What do I confirm? Some Indians are honest. Let's say the truth is all ice creams are delicious. You're also having an ice cream. If the truth is all ice creams are delicious and you're also having an ice cream, will that ice cream also be delicious or not? Logically speaking, yes. Because the statement tells us that all ice creams are delicious. So if your ice cream is delicious, and let's say this is the first ice cream of your life. So when I say your ice cream is delicious, how will you identify your ice cream? Will you say all ice creams are delicious because the first one that I ate was delicious, therefore all of them are delicious? No. You don't know about the rest. You will only know about what you ate. And therefore you will say some ice creams are delicious. So if all A's are B's, then a part of A will also be true. Please understand some to mean at least one. What is the certainty in some? What is the true number behind some? The answer is at least one. So when I say all cats are dogs, will one cat or at least one cat be a dog also or not? The answer is yes. Hence, all cats are dogs, then some cats are dogs will also always be certainly true. Alright. When some cats are dogs, that means when we say some cats are dogs, what are we saying? That there is some overlap of the cats with the dogs. So if there is some overlap of the cats with the dogs, then are the dogs also overlapping those cats? The answer is yes. If you touch somebody, is he also touching you? The answer is yes. Hence, if some cats are dogs is true, some dogs are cats will also be true. Alright? It says all cats are dogs. And the statement that we have to judge is no cat is a dog. If all cats are dogs, can this statement be true? No cat is a dog. The answer is no. Therefore, this conclusion is false. When all cats are dogs, that means all cats are inside dogs, then can we say no dogs are cats? That means no dog is touching the cat. If all cats are inside dogs, then how can it be possible that no dog is touching the cat? So, cats are overlapping with dogs, or all the cats are inside dogs, therefore they are getting overlapped. How can we say that there is no overlap between dog and cat? Hence, that statement is also false. Alright, now it says some cats are not dogs. Now look at diagram 1. It says that some cats are not dogs. Does it say? Answer is no, because it says the statement tells us all cats are dogs. So how can it be possible that some cats are not dogs? Hence, this is also a false statement. The next one tells us all cats are, next one tells us some dogs are not cats. The data given to us is all cats are dogs. If all the cats are dogs, then what is true about some dogs are not cats? It is true in the first illustration. There is some portion that is not a dog. That is not a cat, sorry. There are some dogs that are not cat. But is it true here? Can we say that it is always true? Some dogs are not cats? The answer is no. Therefore, we cannot say certainly true, we'll have to say possibly true. And this forms our table of when all cats are dogs, then how do we relate with the other conclusions? I hope this is clear, everybody. Right, let's move on to the next one. Now, here you are given a statement, no politician is a liar. All right, true statement. Again, don't worry about the truthfulness in the statement. Worry about the data given to you. So the statement says no politician is a liar. You have to, for a moment, believe that there is no politician who is a liar. All right. Now, which statement is this? Out of the four statements that we have, universal affirmative, universal negative, particular affirmative, and particular negative, which statement is this? Look at the quantifier first. Is it talking about all or some? Is it universal or particular? No is a universal quantifier. Does it have a no or not? Answer is yes. So it has to be a universal negative statement. All right. Now, when we say no politician is a liar, how do we represent no politician is a liar? Let's look at the diagram that we have to make. No politician is a liar. Does this represent the category of the politicians? Because we are talking about all of them, therefore we have to represent the whole category of politicians. So let's say this oval represents the entire category of politicians. When it says that no politician is a liar, should liars be overlapping politicians or not? No politician is a liar means there is no connection between a politician and a liar. Therefore, I need a separate oval for liars. Because it says that there is no connection between a politician and a liar. I hope you're getting it. And to understand this better, we should try to create a bar between the politician and liar. This bar indicates that there can never be an overlap between a politician and a liar. I hope the point is clear. Always make this bar so that you're very clear in the mind that they can never overlap each other. All right, so they keep away from each other. Okay, now again we have some set of statements. We have to confirm if no politician is a liar, what is true about all politicians are liar. Can all politicians be liar when not a single politician is a liar? Certainly not. Hence, it is a cross. If no politician is a liar, then can all liars overlap politicians? Because no politician is a liar, that means no politician is overlapping with the liar. Can liars overlap with the politician? Answer is no. Hence, this is also not true. Certainly false. No liar is a politician. If no politician is overlapping the liars, is it also true that liars are not overlapping with politicians? If politicians are not connecting with the liars, then liars are also not connecting with the politicians. So should my third statement not be true? Answer is yes. All right. Next, it says some politicians are liar. If there is no politician who's a liar, can one politician be a liar? Answer is no. Hence, it is false. If no politician is a liar, can some liar have a overlap with the politician? And we also did statement number 3, which says no liar is a politician. If not a single liar is a politician, then can it be true that some liar is a politician? No. Therefore, this is also false. Look at the last two now. The statement is no politician is a liar. That means there is no overlap between a politician and a liar. Some politician. Now, what do you understand by the word some? Some means at least one. All right. So let's say if no politician is a liar, is it true that one politician is not a liar? If I say that no student is a fool, will it also be true that one student is also not a fool? If no student is a fool, then will this also be true that one student is also not a fool? Yes, no means it covers everybody. Therefore, not a single one is a fool is also true. So, should we not understand that if no politician is a liar, then one politician will also not be a liar? hence it has to be always true. Similarly, if no liar is a politician, which comes in a third statement to be true, if no liar is a politician, then even one liar will not be a politician. Hence, the last statement is also true. I hope you are able to understand this. Very, very important. As I told you earlier, it's a part of logic, it's a part of reasoning. So you have to think logically, think from reason point of view, rather than trying to understand it in our the way we understand or communicate in our everyday lives. All right. And we are always there for any kind of doubts or explanations. So in case something is not very clear, you can always come to us, send your mails, and we'll definitely be able to resolve your doubts, right? Next statement is some politicians are honest. Now look at the statement closely. Am I talking about all politicians, universal or particular? It is particular. And does it have a no or not? Answer is no. Hence the statement is particular affirmative. All right. So when I say some politicians are honest, let's first understand what kind of a diagram should I make. This is representing all politicians. Can I take all into consideration when I am talking about some? Therefore, what I will do is that I will take honest people but only overlap partially with the politicians. Some politicians are honest, that means honest, there is an overlap between honest and politicians, but it is partial. Is it representing some politicians are honest? I am showing honest category to be partially overlapping the honest people, the politicians. Therefore, this is a true representation of some politicians are honest. All right. Now, look at this. Some politicians are honest. Is this representing some politicians are honest? Is it representing that there are some politicians who are honest? Is there an overlap between some politicians and some honest people? It's more than that. But then that also gets included in some politicians are honest. Here it is representing politicians and honest completely overlap. So if they are completely overlapping each other, then one will also be overlapped with the other. Therefore, this should also be taken as a true representation of some politicians are honest. So this probably is the minimum overlap, and this could be the maximum overlap that we can talk about. I hope this is understood. All right. So moving on from here, having understood these two diagrams, both represent some politicians are honest, both are true in their own way. What is true about this? Now, it says all politicians are honest. Is the first diagram representing all politicians are honest? No, it only talks about some. Therefore, it is not true here. Is this true here? Yes. Therefore, our answer cannot be certainly true or certainly false. It has to be possibly true. All right. Then it says, the second one says all honest are politicians. Are you sure all honest are politicians here? Only partial honest are politicians, but in the second figure, all honest are politicians. Hence, the answer again will be possibly true. Third one says no politician is honest. It says some politicians are honest. How can you say not a single one is honest? Hence, it is absolutely false. Then it says no honest is a politician. We have understood that there are some honest people who are overlapping with politicians. There are some honest people who are overlapping with politicians. Hence, how can we say that there is not a single honest person who's a politician? Hence, this is also false. Next says some honest people are politicians. If some politicians are overlapping with honest people, then honest people will also be overlapping with politicians. Hence, this is true. Last two, some politicians are not honest. In the first diagram, some politicians are not honest is true. There are some politicians who are not honest. This category is said to be not honest. But in this diagram, we are talking about the entire politician category seems to be honest. Hence, we cannot say that this statement is certainly true. It is true in the first one, not true in the second one. Hence, it is possibly true. Last one also, same explanation. If all honest are politicians, how can we say some honest are not politicians? It may be true here, but not true here. Therefore, we again have to say that this is a possibility.